Hello, do you remember this video? Like, see?
It's a city. Over there. Over there. Like it's far away.
Yes, that city right there. But do you know how far away that city actually is? Let's find it out. That city is literally the farthest thing you can see on the screen. But before that, we need to find out how high we are. Okay, we're at about 38,000 feet. I'm just gonna ignore the last 8 and call it 38,000 feet. So, let me tell you how do you actually find how far that city is. To find that, we just need to find how far can you see at 38,000 feet. To do that, we need to use trigonometry. So, draw a line from the Earth to the center, the radius of the Earth. Right here, the radius of the Earth, and convert 38,000 feet to kilometers, which is 11.58 kilometers. So it's a triangle with 11.58 plus the radius of the Earth as the hypotenuse. So r plus h and the radius of the Earth and the tangent line is x. We need to find the tangent line. Applying Pythagorean theorem, we get this. R plus h whole squared equals r squared plus x squared. Using the binomial formula, we get this. We have an r squared on both sides, so we can cancel that. So we get x equals the square root of 2rh plus h squared. And we get x equals to the square root of 2 times 6,371 times 11.58 plus 11.58 squared, which is this number, the square root of this number here, which is equal to plus minus 384.3. So x equals plus minus 384.3 kilometers. So this city right here is about, that city is about 384.3 kilometers away. And I think that's San Francisco. That city is probably San Francisco. Because I think I can try to prove it. And just for you to know, this is a Pythagorean theorem.
Hat der Dreieck die Seitennamen A, B und C mit einem rechten Winkel gegenüber von C. Dann hast du gleich zur Berechnung eine Formel parat. Denn dann gilt A Quadrat plus B Quadrat ist gleich C Quadrat.
So that is why we get this formula here. And we got x equals to plus minus 384.3 kilometers. So yeah.
It's far away.
And one more thing. On the videos that so in this part where I use the satellite Wi-Fi to save the videos, I keep on saying Starlink. But there are multiple evidence that says that Delta airline actually used Viasat internet. So which actually adds another very interesting research, trigonometry research. Now, so if you look at the map, the airplane is right here. The airplane is about in Gardenville. The airplane is about in Gardenville. And maybe we can try to find the exact distance from here to the Viasat satellite. And to find that exact distance, we need to use the law of cosine, which is similar to the Pythagorean theorem. So the VSAT satellite is about 88.9 degrees west. And again, this is the radius of the Earth. And the height of the VSAT satellite right above that point is 35793 kilometers, plus the radius of the Earth, which is 6,371 kilometers, which is this number here, and we will call that A. Gardner latitude is about 38.9413, and the other one is about 11.975696, and that's a negative number. So the absolute value of the satellite one and this one, the difference is about 30.8496 degrees. And remember the law of cosine? Here. Here.
C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Kosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2bc mal der Kosinus von Alpha. Dieser Satz gilt im allgemeinen Dreieck, wenn die Winkel Alpha, Beta, Gamma und die Seiten A.
Oh, the law of cosine, which I just put it here. The distance we're gonna find, which is here, the distance from our plane to the VSAT satellite, it's this, and we already knew that one side is this, the distance from the surface of Earth to the satellite at that point, and plus the radius of the Earth. So the distance from the core of the Earth to the satellite is this. The core of the Earth satellite, it's this much kilometers, and the radius of the Earth is this much kilometers. And the angles here, let me show you how I got the angle. I did some trigonometry here. And so cosine this times cosine this, which is 48.1067 degrees here. So theta is equal to 48.1067. And since the law of cosine says this, maybe I need to use a theater mode.
C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Kosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2bc mal der Kosinus von Alpha. Wenn die Winkel Alpha, Beta genauso auch mit C, A und B, denn du kannst die Seiten nach. Hast du mal einen Sinus auf einen Winkel kommen, denn hoffentlich hast mit etwas Übung schaffst du das in wenig Grad. Minus 2AB mal der Kosinus von Gamma.
So to find the distance here, we do d squared equals r squared plus a squared minus 2ra cosine theta, which is equal to d squared equals 6,371 squared plus 4,216 4 squared minus 2 times 6371 times 42164 times cosine of the degrees of 48.1067. And all of that is this number here. So take the square root, and we'll see that d is equal to plus minus 38,205.3 kilometers. So in this video, the distance from me to the VSAT satellite is exactly this much kilometers, which makes sense because if you see the video saving speed, you can see it if you see the video saving speed. The signal of light takes about like takes about like 1 second. Some of that time is during the computer's processing speed on the YouTube station, but most of that time is probably the light speed traveling from the plane, my computer, to the router, to the VSAT satellite, back to ground on a VSAT satellite station, to the YouTube station and back, to the VSAT satellite, and back to my computer to confirm it has been saved. So, yeah, the speed of light will take some time. And then another one here is that this very beautiful city down there. I actually recorded the coordinates, the precise coordinates here. And let me just tell you part 2 here. This is the coordinates. That city is called Spark. And the coordinates are this, and this. And again, doing some trigonometry, we find that the angle is this 48.5415. The theta angle. And we again need to find the distance from our plane here to the satellite. So we'll do some trigonometry.
Ist erfunden und mit etwas Übung schaffst du das in wenigen Sekunden. C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Kosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2BC mal der Kosinus von Alpha.
And he's gonna explain why it works.
Ich hoffe mal,
I don't understand anything he's saying because he's saying it in German.
Das Dreieck geteilt wird und rechte Winkel entstehen.
But I can visualize
den
this.
Satz des Pythagoras nehmen. B Quadrat ist H Quadrat plus X Quadrat und C Quadrat ist H Quadrat plus A minus X Quadrat. Da stellen wir beides nach H Quadrat um und setzen gleich. Aber fehlt da nicht der Cosinus? Kommt ja gleich, ich weiß, aber erstmal wird hier A minus X Quadrat addiert
So
und
the law of cosine is similar to the Pythagorean
das dient
theorem.
einem Zweck, das X Quadrat fällt weg und wie der Cosinus da reinkommt, folgt nun direkt. Wenn ich hier das eine Teildreieck so sehe, dann ist der Cosinus von Gamma x durch b. Das heißt, x ist der Cosinus von Gamma mal b. Das Quadrat plus b Quadrat minus 2ab mal der Cosinus von Gamma.
So to find the distance of me here to the VSAT satellite, no, not this one, from me here to the VSAT satellite, to find the distance, from me here to the VSAT satellite, we need to find this angle. And we need to use the law of cosine again. D squared equals this squared plus this squared minus this cosine of 48.5415. And all those numbers together is this number, so we take the square root of both sides, and we get D equals plus minus 38245.12 kilometers. So this is the kilometers of me here to the VSAT satellite. And it also makes sense because look at the saving speed. It's so slow. I bet a lot of them are both the computer processing speed on the ground station, and a lot of them are, and the rest of them is the speed of light, taking time to travel this much kilometers 4 times. And finally, we got this. It does look like a toy. And again, this is our final part, part 3. We are above this city right here, Drowning, and I also have a precise coordinate. The coordinate of it's this and this. So do some trigonometry, we find theta, angle theta, is equal to this number, 43.628,93577. This is the angle theta. And remember this.
Von Gamma mal B, das setzt sich ein und hab hier nur noch Gamma A, B und C. C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus A Quadrat plus C Quadrat minus 2AC mal der Kosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2bc mal der Kosinus von Alpha.
I think he's a German mathematician.
C Quadrat ist A Quadrat plus B Quadrat minus 2ab mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2ac.
Yeah, he's a German mathematician. I think so.
Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2bc mal der Kosinus von Alpha.
So to calculate the distance here, we do d squared equals the radius of the Earth squared plus the radius of the Earth plus the distance to the VSAT satellite squared minus those two numbers times 2 and times the cosine of theta. And theta is equal to 33.6289357. So all those numbers together is equal to this number, and d is equal to the square root of that number. So d equals plus minus 37808.94 kilometers. So this is how far I'm to the satellite in that video. And it again makes sense because look at the speed of light. Again, many of the time is the computer processing on the ground processing that video, but I think like other part of the rest of the time is the speed of light traveling the distance back and forth 4 times, traveling this much kilometers back and forth 4 times. So yeah, today we did some trigonometry. So thank you so much for watching today's video, and thank you for doing trigonometry with me. Bye!
Der Cosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Cosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2BC mal der Cosinus von Alpha.
This video, remember this? The city there?
Look at the city. Over there.
I want you to guess the distance of the city there and put it in the comments. Because I can find out exactly the distance of me on the airplane to that city over there using trigonometry. So we can do it by first looking at the height of the aircraft. 38,000 feet. There's an extra 8, but I'm just gonna ignore that and call it 38,000 feet. We can use trigonometry to figure it out. Here we have the height 38,000 feet is also 11.58 kilometers. So we have, and the radius of Earth is 6,371 kilometers. So we draw a tangent line from our airplane height down to the ground. We draw and this is the line, the distance we need to calculate. Our radius of the Earth, we are going to draw it here. And for this, hypotenuse is going to be the radius of the Earth plus the height of our airplane, 11.58 kilometers. And according to the Pythagorean theorem, r plus h whole squared equals to r squared plus x squared. According to the binomial formula, r plus h whole squared can be written as this. So r squared plus 2rh plus h squared equals r squared plus x squared. And we get x equal to the square root of 2rh plus h squared. So x is equal to the square root of 2 times 6,371 times 11.58 plus 11.58 squared. And x is equal to the square root of this number, and the square root of this number, because this number is the product of the multiplication and the addition and the exponents in here. So x equals to plus minus 384.3 kilometers. So in this video, this city over here is exactly 384 kilometers. Because according to the Pythagorean theorem, we got x equals to plus minus 384 kilometers. And this is the Pythagorean theorem.
Hat ein Dreieck die Seitennamen A, B und C und einen rechten Winkel gegenüber von C, dann hast du gleich zur Berechnung eine Formel parat, denn dann gilt A Quadrat plus B Quadrat ist gleich C Quadrat. Hat ein Dreieck die Seitennamen A, B und C und einen rechten Winkel gegenüber von C, dann hast du gleich zur Berechnung eine Formel parat, denn dann gilt A Quadrat plus B Quadrat ist gleich C Quadrat.
Because in this video, the distance of the city, we have a right angle right here, right angle right here. Because this is a tangent and this is the radius, so we have a right angle here. So radius plus height, radius, and the distance we need to find. So according to the Pythagorean theorem, this, we simplify it, we plug in our numbers, we get the square root, and we get x equals plus minus 384.3 kilometers. Now take the principal root, x is only equal to positive 384.3 kilometers because there can't be a negative distance. So the city over there is 384.3 kilometers away. And I guess that city is probably San Francisco. That's my good guess. That city is probably San Francisco. Thanks to the Pythagorean theorem, we are able to find the distance between me on the airplane to that city over there using the Pythagorean theorem. This is the logic behind it.
Was die Seitenlänge a plus b hat, also ganz formell gesprochen a plus b zum Quadrat. Und wenn ich jetzt in der Mitte c Quadrat sehe, dann sehe ich auch, der Rest ist 2 mal a mal b. Die Klammer auf der linken Seite loszuwerden, nimmst du die erste binomische Formel her. Subtrahierst du 2ab auf beiden Seiten, dann lass es doch klar, steht nur noch das da, was zu beweisen war. Die Seitennamen A, B und C mit einem rechten Winkel gegenüber von C. Dann hast du gleich zur Berechnung eine Formel parat, denn dann gilt a Quadrat plus b Quadrat ist gleich c Quadrat.
And because of the Pythagorean theorem, we know the distance between me on the airplane to that city over there.
Over there. Like it's far away. But the city is far away. Still
384.3 kilometers away. And we are going to calculate the VSAT satellite between me here to that, to the distance between me to the VSAT satellite I'm using in this video. So I already took the coordinates. Which is the VSAT satellite. The coordinates of the VSAT satellite is here, and the coordinates of the airplane in the video right here. That coordinates, exact coordinates, it's this thing, this, and this. Sorry, it's this and this. So one of the degrees is 38.94 about that, and the other one is actually 109.76 about that. Since this is a negative, we do this number or one of the other coordinate point plus the satellite coordinates, and they take the absolute value, which is 30.8496 degree. Do some trigonometry, do cosine 38.94 times the cosine of 30.8496 and take the arctan of both to get back to the degrees. When we get back to the degree, we get 48.1067 degrees. So this is the angle theta right here. This is me here to the satellite. We need to find the distance. This is the radius of the Earth. This is the radius of the Earth plus the distance directly of the satellite to the surface of the Earth. So we have a triangle here with this angle. Again, radius of the Earth plus the distance from that ground to the satellite, and the distance from me to the satellite, which we're gonna find here, angle theta. We got this. And we know the law of cosine, which I'm gonna borrow from this video again.
C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Cosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Cosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2bc mal der Cosinus von Alpha.
So doing the trigonometry, which is here, plug in the radius of the Earth and the other number I just talked about, radius of the Earth plus the distance, direct distance, minus 2 times these two numbers. And not to mention, for the first of these two numbers, add a square to both. And multiply the whole by cosine the theta degree that we just found out. And together, the product of this is equal to this, so d is equal to the square root of this number, which is d equals to plus minus 38205.3 kilometers. So the distance between me and the ViaSat satellite in this video is exactly that much. The distance between me and the ViaSat satellite in that video is exactly 38205.3 kilometers. So when I click save, when I click the, let me get to a better angle. When I click save, light travels that much distance back to my computer and saves the video. Back to the computer, to the YouTube station, do all those journey and save the video to the internet. Again, light will have to travel 38205.3 kilometers. 4 round trips. Because it needs to go back to not only go back to my computer, but obviously have to go to the YouTube station for it to get to the public internet.
Because this is not medicine. The PMDA might not want us to see it, but who cares? We're at 35,000 feet. No PMDA is going to jump up.
And no PMDA is going to jump up to that much distance. No PMDA is going to be able to stop a satellite at 38205.3 kilometers. And also, this guy, the law of cosine, will defend us from the PMDA. This guy, the law of cosine, will defend us from the fucking PMDA who's trying to fucking stop me. Or if it's using Starlink, or maybe I'm wrong, maybe if it's using Starlink, Elon Musk will defend. Yeah, the timing here, if you use a stopwatch to time it, that's about the time it takes from the internet signal from my computer to travel at the speed of light to the ViaSat satellite through the router, for the satellite to go to the ground station and the YouTube station to communicate together to save the video. Ground station send the signal back to the satellite send the signal back to the computer to confirm it has been saved. So that whole journey is probably the speed. That whole journey is the light traveling the distance of 38205.3 kilometers 4 times, and the speed of light is incredibly fast. So it only takes a few seconds. Not a few seconds. Only takes like 0.7 seconds, not even 1 second, for the light to make that journey 4 times. And we know, according to the law of cosine, we know the distance.
B und C, dann geht das Ganze doch genauso auch mit C, A und B. Denn du kannst die Seitennamen tauschen, doch das Dreieck bleibt gleich. Und daher sind 3 Gleichungen als Kosinussatz 1. Wie auch immer. Hast du mal ein Dreieck vor dir gegeben, nach Konkurrenzsatz SSS durch die 3 Seitenlängen eben, dann kannst du durch den Kosinussatz auf einen Winkel kommen. Denn hoffentlich hast du mittlerweile mitbekommen, dass der Satz die Relation zwischen einem Winkel und 3 Seiten beschreibt. Und damit bist du auch schon bereit. Die 3 Seitenlängen kennst du, setzt sie in die Gleichung ein und schon fehlt nur noch der Winkel. So soll das ja auch sein. Nach dem stellst du dann um und hast ihn damit gefunden. Und mit etwas Übung schaffst du das in wenigen Sekunden. C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma.
Yeah, so thanks to the law of cosine, I'm able to save these videos at 38,000 feet with no interruptions from fucking PMDAs or any shit like that. So yeah, thank you to the law of cosine and satellites. And this is our next video again. This beautiful city down there, as you can see, that is called that city is named Spark, and I took the coordinates of that as well. I took the coordinates of that as well. Yeah, toy cars, toy buildings there. So I took the coordinates of that as well. Right here, the coordinates is this and this number, cosine this number, times the cosine of the absolute value difference of this number, and then plus this number, because this is a negative, so the difference becomes a positive, the plus sign, because 2 negative is a positive, blah 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 blah, which is equal to this, and we get the and in total we get the degrees of this. So our angle theta in this case is this 48.5415. This is our angle theta in our part 2. So we are again calculate the distance from me to the satellite. And remember the law of cosine.
Quadrat hast ihn damit gefunden und mit etwas Übung schaffst du das in wenigen Sekunden. C Quadrat ist A Quadrat plus B Quadrat minus 2AB mal der Kosinus von Gamma. B Quadrat ist A Quadrat plus C Quadrat minus 2AC mal der Kosinus von Beta. Und A Quadrat ist B Quadrat plus C Quadrat minus 2BC mal der Kosinus von Alpha.
So again, thanks to the law of cosine, we did the square root of the product of these numbers and the cosine of this angle theta degree. And the square root is plus minus 38245.12 kilometers. So distance between me and the VSAT satellite is exactly 38245.12 kilometers. So this is the distance between me and the VSAT satellite. And again, and when I click save, look at that bar. This is the time it takes light to travel 4 times the distance and the computer processing speed combined together. 4 times the distance of 38245.12 kilometers. So the speed of light is incredibly fast. So again, as soon as the save button is clicked, light travels 38245.12 kilometers to the satellite, back to the Earth, to the VSAT station, to the YouTube station, back to the VSS station, which the distance is short, back to the satellite and back to the computer. So 4 trips, 2 round trips, 4 trips. See? The signals travel to the VSS satellite at 38245.12 kilometers. So the satellite send it back to the Earth, to the ground station and the YouTube station to save this video to the public internet.
And we're done.
So again, thanks to the law of cosine, we're able to do it.
Ich hoffe mal, es ist jedem klar, dass durch die Höhe über der Seite A das Dreieck geteilt wird und rechte Winkel entstehen. Von daher kann ich den Satz des Pythagoras nehmen. b Quadrat ist h Quadrat plus x Quadrat und c Quadrat ist h Quadrat plus a minus x Quadrat. Da stellen wir beides nach h Quadrat um und setzen gleich. Aber fehlt da nicht der Cosinus? Kommt ja gleich, ich weiß, aber erstmal wird hier a minus x Quadrat addiert und mit
So again, thanks to the law of cosine, we're able to use the satellite reliably to save these videos.
Nun direkt. Wenn ich hier das eine Teil Dreieck so sehe, dann ist der Cosinus von Gamma x durch b. Das heißt, x ist der Cosinus von Gamma mal b. Das setzt sich ein und hab hier nur noch Gamma, a, b und c. c Quadrat ist a Quadrat plus b Quadrat minus 2ab. Da der Cosinus von Gamma b Quadrat ist a Quadrat plus c Quadrat minus 2ac mal der Cosinus von Beta und a Quadrat ist b Quadrat x durch b.
And finally, in this video above Los Angeles, I also took a coordinates. Above Los Angeles, I also took a coordinates. Drowny, that's the city, and the coordinates of Drowny it's this and this. Again, you know the drill. The difference between the VSS satellite and this, the absolute value, and to cosine this and cosine this times together equals the angle theta if we take the arc cosine, or should I say arc cosine. So in this video, the distance between me and the VSS satellite is this distance we need to find. Again, you know the drill, you know what those two numbers mean. This is the radius of the Earth, this is the radius of the Earth plus the VSS satellite distance directly on the Earth's surface. And we already got the angle theta, which is this 43.6, about that. That's the angle theta. So, and again, using the law of cosine,
Das heißt, x ist der Cosinus von Gamma mal b. Das setzt sich ein und hab hier nur noch Gamma, a, b und c. c Quadrat ist a Quadrat plus b Quadrat minus 2ab mal der Cosinus von Gamma. b Quadrat ist a Quadrat plus c Quadrat minus 2ac mal der Cosinus von Beta und a Quadrat ist b Quadrat plus c Quadrat minus 2bc mal der Cosinus von Alpha.
see? So when I use the satellite to save the videos here and here,
Burn down there is a twice.
yeah, it's a toy city because it's so small. Not trying to be disrespectful, but it does look like a toy.
This is actually so.
See, when I click save, the distance you get is this much, the product of this much plus the times the cosine of the angle theta we just got equals d equals the square root of this number, which is equal to plus minus 37808.94 kilometers. D equals this. D equals plus minus 3.7808.94 kilometers. But we take the principal root, so we only use the positive answer. So when I click the button save here, the satellite, the signal is traveling 37808.94 kilometers and 4 times to get to a ground station and back to my computer, and to get to the ground station so it can go to the public internet. So in this video, you might be asking, how do we know exactly the distance from me to the Viasat satellite when we are saving these videos? How do we know the exact distance? Well, as I already said, we calculated them through the law of cosine. But if you want a better proof, I guess, we can use a decimal graph and plug in our degrees right here, the degrees we calculated from the law of cosine. So 48.1067, which is this. So as you can see, here we have a graph of the cosine, the graph here of how we do the law of cosine, the g of x, the square root is a wave function called the cosine wave. And if we plug in our number here, we can see the coordinates. We can see the exact number right here, which matches the number we calculated, or at least about matches it. And for the Spark City right here, the beautiful city here, we know the distance from here to the satellite because right here we know the angle theta. We know the angle theta we calculated. Here we know the angle theta here. So the Spark City is right here. On the cosine wave is right here. This number here, which matches the number we calculated here, the square root. And finally, when we are in Los Angeles on the aircraft, we calculated this exact distance from me to the satellite on the airplane using this graph. So it's the exact distance from me to the satellite that we are saving this video. The satellite that I used to save that video, again, yeah, it's the distance here because on the cosine graph, sine, cosine, the cosine graph, the wave here, plug in the point of the x, and we get this number here, which matches this perfectly, the angle theta here. So when I click save, this is how long it took light to travel to the YouTube station on the ground. And again, the city there, we know exactly the distance because turn on the Pythagorean theorem graph and turn on the other thing. Right now, we can see the graph right here, this with the square root here, and our point intersect exactly right there. Again, the radius of the Earth, blah blah blah. Converts 38,000 feet to kilometers. And we get the distance x, the tangent line, is exactly is exactly this number here, which is about 384.3. It's probably an irrational number, but approximately that. So this is how you can calculate all those trigonometry stuff in those videos. Again, this is how long it took light to travel from the satellite to the plane to the ground station.
This is actually so.
Again, this is the speed of light traveling from the satellite to the plane to the YouTube station and back. Again, this is how we can calculate that using this decimals here. I'm also going to turn on all the derivatives we have here. Again, this is our cosine wave here. And we can stretch this out. And we get the real cosine wave. Not the real one, but the better one. And we can find, again, the exact distance from me to the satellite on those things, on the aircraft, because we found the angle theta already with doing some trigonometry. So according to the graph, that's the exact distance as well. So this is how we can find the exact distance. And to show you the whole graph, x here, cosine x, put x here. G of x, x here. This is the derivative of that cosine graph.